Hi, this is Dr. Jenny Mitchell, and this is the second video in the Chapter 2 Trends and Analysis. As you can see here, we're working with the same data that we used when we did descriptive statistics. We're going to, if I click on the data here, I'm not including the total, and I go to my data analysis, you'll see that here's regression. I say OK. Now in this, it's actually populating up so we see the data, and I'm not going to run it again, but I'll show you where these come from. Our Y range is this column that is the revenue. Our X range is the wins column. I've actually clicked some boxes here, so I just clicked everything I could. The confidence level, the residuals, standard residuals, and so on. You may find in some textbooks that they'll talk about Excel may not do something quite as well for residuals, but we're going to accept it just the way it is. I'm going to go ahead and say cancel here because I've ran all these, and we're going to look at some of this data so you know. This, when we're looking at multiple R, this is the correlation coefficient. You'll notice it's 0.92. A perfect fit would be 1. A perfect fit would be -1. So essentially this can either be a negative or a positive correlation here, and it is our coefficient. This is a very high positive correlation, which is a good thing. The R squared is called a coefficient of determination, and it's telling you about how many of your points fall on the regression line. In this case, 85% of our points fall on the regression line, which is very good. Keep in mind, this is only 11 observations, so we can't make predictions on this past the wins. So in other words, we're probably looking at from 3 to 12. If we have wins anywhere from 3 to 12, we're going to be okay with using this data somewhat to predict something. If we go on down here, the standard error is basically, it's not the same as the standard error in our descriptive statistics. It's about precision. So it's about precision around that regression line. And then we have this little table here, and you may have seen this table before in research papers and so on, where the ANOVA table, where it tells you the degrees of freedom. The SS is the sum of squares, the MS is the residual sum of squares divided by regression, blah, blah, blah. So we have a lot of stuff here. I shouldn't have said blah, 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 but you get my idea. There's a lot here, and at first you may not know what all this means. This is very significant. If you've ever seen a number like this with the E and a 0.05, it's trying to tell you something that that this is very significant. You can actually calculate what that number is, and I think I've included that in the textbook so that you can figure that out as well. You'll notice that I have highlighted this green and this green is because they are related. So our p-value, especially when we're only talking about one variable here, that's why we see that. So we've got a good ANOVA here. So this is telling us this is a pretty strong predictive model. The intercept, if you think of a chart, the intercept, I always think of the intercept as my y-axis. So in essentially, this is telling me that even if I didn't have any wins, I'd make that much revenue. That's how I see it. And then my X variable is the more wins I have, this is X variable 1, then I'm adding this much more revenue to it. So my formula is y equals a plus x times b times x, or x times b, either way. So if you calculate this out, I've actually done that over here for you to see this, as I've ranked these out here. So I've done the actual revenue, which we had from 2010 to 2020, and then used the formula to predict it. So you'll notice there's variation in this, but when you get down to the end, they're very close. So there is some variation. Remember, it's only 85% of those points fall on the regression line, so you're going to have some variation. But basically, it does a good model of predicting. So we've got that down here. And if we look at our predicted value here, with the 0 and 12, then this actually would be good information for you to be able to do scenario manager, where you would say, if we have this kind of win, we can be pretty comfortable predicting our revenue will fall in this range. So essentially this is doing a pretty good job of that. And here I've plotted the actual revenue versus the predicted revenue, so you can see how closely it aligns, which that's giving us a pretty good idea that this is a pretty good model for us to use for prediction. I would be a little leery because we don't have that many years of data, but remember, if you just continue to keep gathering your data, your model will get better and better. The more observations you have, obviously, the better the model. One last thing that I want to make sure of is that we want to make sure we have normal data. There's a thing, I always call it just the bell curve. The bell curve essentially is talking about this chart, or this diagram. I'm sure you've seen it before. It's sometimes referred to as the empirical rule, but if you'll notice here, it's showing us the 68%, the 95%, and the 99%, of data can fall under a normal distribution. So that's important to understand your data, and that's why when we're looking at things like kurtosis and skewness and all that, we're trying to see if we have normal data.